Okay, good afternoon, everyone. So first of all, I would like to congratulate the organizers for successfully organizing this knowledge-sharing platform for all of us. I would like to thank the organizers to giving me an opportunity to participate in the symposium. Today I will be talking about nature-inspired computing. So in this I will be discussing about the different algorithms which is inspired from the nature, and I'll be focusing mainly on TLBO, that is teaching learning based optimization technique. So nature-inspired computing is basically a science of computing that got inspiration from nature. And it has already been realized that many of the problems can be solved if we look closely to the nature and we observe the behavior of the natural creatures. So when we talk of nature-inspired computing, we talk of nature-based intelligence, we talk of computational intelligence. These are basically mature branches of artificial intelligence. Both of them basically have some common features. For example, if you take any problem, they will mimic our natural system or our natural process that can construct a solution which will be optimal both in terms of quality and also in terms of robustness. So in computational intelligence, you will find that these things are always implicit, like nature-inspired algorithms, fuzzy logic systems, neural networks, AI, support vector machines. So let us talk about the inspiration. We need to understand that every problem comes with a solution. The only thing required is to widen our knowledge. We need to closely look to the nature. So when we talk about the nature-inspired computing or computational intelligence, we talk about the artificial life. So artificial life is something which is a human-made system that possesses some essential properties of life. There is one thing to understand, that with the power of nature and with the efficiency of computers, we can do two kinds of research. We need to understand that how the computational techniques can help us to study biological phenomena, as well as we need to explore that how this biological phenomena can help us to solve computational problem. So if you look at this figure, you can relate that human is actually inspired from nature for a long time. So if you look at this beak of the bird, this gives a very creative engineering design that is used for designing a bullet train. Similarly, you can see here, nature provides us a very effective and a simple solutions. And these designs are itself very scientific. So these are some examples which we can conclude that nature inspires us to come up very innovative designs, and these designs are purely inspired from nature. Now, in nature we have billions of such designs. They are existing at the level of molecule, they are existing at the level of organism, they are existing at the level of ecosystem, and they are existing there for a very longer age. It's been existing there. The only thing we have to focus and we have to identify that how they are helping us to come up with the solution. Now, nature is not only helping us to come up with the innovative physical design, but if you look to the behavior of the natural creature, like how the ants work, how the birds work, how the bees work, they also guide us to come up with an excellent solution. So let us see how they are helping us. So to understand nature, we need to first see that what are the basic components of nature and how we can use these components to solve our problems that we see in our natural life. So in nature, we have 4 basic components. They are said to be self-optimization, self-healing, self-learning, and self-processing. Self-optimization means every component of nature know how to efficiently use the resources which are available to them. Self-healing means when any of the elements in nature comes into problem, they know how to come out of that. Self-learning and self-processing is a kind of mutual thing that works together. The element of nature learned from the environment, they process it to adapt with the system. So these are the fundamental things that exist in nature, and we need to understand how these properties can be used to solve our hard problems. So in day-to-day life, we deal with optimization problem. Optimization is achieving the best with the available resources while satisfying the constraints. And if you observe, you can find that nature has optimized almost everything. And also in our day-to-day life, we always look for optimization. If you want to go to your office, you are looking for an optimal route so that you can reach in a minimum time. If you look at the routers want to deliver the packet in the minimum time from the source to destination. And efficient machines want to process all the tasks in the optimal way. So optimization is everywhere. So the thing is, the more you understand the problem, you will be able to understand how the optimization is applicable. So what is the goal of optimization? So when we talk of optimization, we talk of maximizing, we talk of minimizing. That means we must have some maximizing function, we have some minimizing function, and the goal of optimization, we can say mathematically that we are looking for a variable whose value can either maximize or minimize these objective function. So we have different kind of objective functions are there, and their complexity depends on number of objective in hands. So there are single objective functions, there are multiple objective functions, and we have many different techniques are available to solve these objective functions. We are calling it a traditional approach. Though they are very straightforward, we can find a solution. But then we will find that there are certain problems exist. We call it a hard problem that cannot be solved using these techniques. Because if we try to apply these techniques, you may find that running time is too high. The computation complexity becomes too high. If you are familiar about the algorithm background, if you talk about the 8 queens problem, traveling cell problem, these are said to be NP hard problems because we cannot apply the direct technique here. And even to solve this kind of problem, it may take like 100 years or 200 years with the use of efficient computers. So we have a different approach that is inspired from the nature that is called stochastic. So in the deterministic way, we have a defined data set, and when you do iterations, you are using the same design parameters, the same function values. But when we talk of stochastic methods, these includes randomness. Randomness in the population, randomness in the strategy. So all these techniques which I have shown here, these are derived from the different phenomena that exist in nature. And they are very much efficient to solve many of the hard problems which are assumed to be highly complex. These are the names of some of the techniques which have already been used in many of the problem solving. So out of these, I'll just give you an idea of ant colony optimization, that how this technique is help us to solve the problem, so that you can have an idea that how the nature is helping us to solve different problems. And then I will show you that how the TLBO is actually used for optimization problems. So ant colony optimization. This is also one of the widely used algorithm for solving the optimization problem. And here, the term I am using is Swarn-Intelligence. Swarm means group. So here the group intelligence is used to solve the problem. So we have a category of problem where the population is working together to come up with the solution. So ant colony optimization is also comes in this category where all the ants are working together. They are working collectively to come up with the solution. So the problem here is ants want to search the food. If you look at the ants are very weak creatures. They don't have very good visible power. They don't have any good communication power. But still, they are doing excellent job because nature has given something to them. So we got some very interesting result out of the two ant properties. This is called stigmergy and foraging. Foraging is an act of searching the food, and stigmergy is a act of indirect coordination through the environment between the two agents or the two actions. What actually is happening here? When the ant starts searching the food, they have no idea where the food is existing. What they are doing, they are leaving some traces, some marks when they search the food. They are leaving some chemical compound, and that is called pheromone. And this pheromone is actually evaporates over a period of time. When the ants search the food, they leave this chemical compound, and it's a kind of help to the successor ant to follow this path. And if you look at the entire, means the way they work, they will able to find the solution. Now, there's one simple example I have taken to make you understand how the things are working. Let's say there's a nest, that is the origin where the ant is staying, and there's a food. And if there's a straight path, the ant starts searching for the food, and they may reach to their destination straightforward. So there is no obstruction here. If you look to the second image, so here we have one obstacle here between the nest and the food. So now there are two possible ways. One is ant can go to the upper path, and otherwise the lower path. We can easily see that the upper path is actually the shorter path than the lower path. Ants have no information how to reach to the food, so initially they move randomly. They can go in both the direction, but while moving to search the food, they are leaving the traces. We are calling a pheromone. And the ant has a property, they like to move to the path where there has denser pheromones. So after a period of time, it is observed that the pheromone which is laid on the shorter path becomes more denser, means the concentration will be getting denser, which is at the shorter path. But at the longer path, if you look, because the path is longer and the pheromones are getting evaporated over a period of time, so the rate of getting evaporation of this path is faster. After some time, you will observe that because the path is shorter and ants keep on coming, so the rate of evaporation of this pheromone will be less compared to the down path. So there will be no pheromone existing, because after some time, all the ants will follow the shorter path, and actually they have find the shortest path without any information. Now this is an excellent thing which can be used to find the shortest path. We have a problem that is called traveling salesman problem, where one person is to start from one city. There are n numbers of cities. He has to visit all the cities in such a way so that he can cover entire city back to the origin in the minimum time. So we are looking for the shortest path. So this can be used. So it seems like it's very straightforward. It is very useful, but again we have some challenges. Yes, it is true that this ACO can be used for dynamic applications, but its implementation is not straightforward. We need to think on some aspect like the pheromone, how we are going to represent this pheromone, how you are going to represent mathematically the rate of evaporation. In the entire process, we are doing two loops. One is the ant has to reach from the source to destination, and then how many times we need to see this process to get the final solution. So there are many issues are there, but we understood that this is possible. So if you are able to represent the natural phenomena in terms of mathematical equations, we can get excellent results. Now I want to focus on TLBO, that is the teaching learning based optimization technique, which is recently very much used in many of the problems. So far we have seen that nature has inspiring us with the physical designs. There are so many designs existing in the present world which has got inspirations from the nature. We have seen that nature is inspiring us with their behavior of the natural creatures like ants, bees, birds, flies. Nature is also inspiring us through the social phenomena that exist in nature. This is the example which got inspiration from the social phenomena. What does it mean? This TLBO is getting inspired from the principle of teaching learning. So in the teaching learning process, initially all are learners. We all start learning from the environment, and the one who get the maximum knowledge is said to be a teacher. So we are assuming the teacher is something which is having means he is the most intelligent person. So he will learn from the system. The one who gets the maximum knowledge becomes the teacher. And then this process keep on going, because learning is a continuous process. Then teacher, again as a learner, keep on learning, and this process keeps on revolving. Once teacher gets the absolute knowledge, then the process will stop. Or you can say, if you are applying this kind of scenario in a real problem, and once you get the optimal solution, you have to stop at that point. So here, if you want to apply this to any of the real world problem, you must have some design, you must have some objective function, you must have certain goals. Your function must be of maximizing or of minimizing nature. Now this problem is very suitable for open-ended problem, where we have many feasible solutions are possible. Actually, we are aware about the solution. Like when we talk of traveling salesman problem, we know all the possible routes, but our objective is to come up with the best solution, the optimal solution. So such a space refers to the feasible solution. Optimization method. So here in this process, we keep on doing iteration for the best solution by using this teaching learning process. And we may have some design variable as well. So we'll see how all these things will combine together to solve any problems. We'll see. So first understand why this technique has been evolved and why it is so much useful. If you talk about population-based algorithm, they have two categories. One is evolutionary based and the other is Swarn-Intelligence based. And they are probabilistic in nature. They need some common controlling parameters to get the solution. Along with the common controlling parameters, they also need some algorithmic specific parameters. So if you talk any of the algorithm, they always need some algorithmic specific parameters. And the main challenge of using these population-based algorithm is you need to do the proper tuning of these parameters, because it affects the performance of the algorithm. And if we are not able to tune these parameters, then we may have a chance to struck in the local optima. There is also a chance that your computational efforts may increase. So in the previous algorithmic approach, we are dependent on these algorithmic specific parameters, which is a kind of challenges to deal with. But the beauty of this algorithm is there is no need of algorithmic specific parameters. We only need some common control parameters, that is the population size, which we are dealing with, the number of generations, that up to how much optimality you want to attain. So this is a TLBO is a multi-objective optimization based problem where we need a population. So population here is the number of learners, the student. We have design variables. Design variables you may think of as subjects, subjects offered to the student. And the possible solutions, because we need a feasible solutions. So grades of learner in each subject. So the scenario is all about teaching learning. And now we have to see that how this is applicable to solve the problem. So quality of the solution will be given by average results of learner considering all subjects. And the best solution will be the element which attains the maximum score, or we are calling as a teacher. So this algorithm runs in two phases, a teacher phase and a learner phase. So in the teacher phase, the learning is from the teacher. And in the second phase, that is called the learner phase, the individual element of the population or the student who have already attained some knowledge from the teachers, now they're in a position to attain the knowledge from the environment and also to give knowledge to their peer elements. So that is called learner phase. So in the teacher phase, The objective is the teacher tries to improve the mean result of the class for the course he is teaching. This is the objective of teacher phase. So here we are having some variables if you want to implement. So that we have M is the number of subjects that is offered. So in terms of mathematically, the number of design variables x1, x2, x3. So here we are saying that number of courses which are offered to the student will be the design variables. M is the population, that is the number of learners or the number of students. And Mij refers to the mean result of the learner in a particular subject J at any iteration I. K-best is basically the best learner, which attains the maximum result out of the first phase. So this is the key idea of getting the solution. So in this, what we are doing, we are actually finding the difference between the existing mean result of each subject and the corresponding result of the teacher for each subject. So if you look at this formula, that is actually provides a training to the student or the training to the learner, training to the element of the population. So here you can find Ri is a random number because we see that in the real world problem we have random data. So this is to match with the real problems. This Ri is used that involves randomness. Tf is a teaching factor whose value is 1 and 2, and this can be chosen with equal probability using this formula. So once you find this value, these values are added to the previous value, and then with the new value you have to find the result. If the result of the objective function is going to improve, then we consider this change, otherwise we will not consider it. Then comes the learner phase. So in the first phase, teacher phase, we have used that formula, got the new value, and this value, if it improves the overall objective function, we keep it, and then we move to the next phase, that is the learner phase. So here the learning is happening by the interaction between the two peers or the two elements of the population. So this is how the algorithm is there. I'll just give you the basic idea. So the learning is only possible when two people communicate with difference in knowledge. Then only one can pass his knowledge to the other. So we have to select two learners whose values must be different, and then we check that if the objective function of first learner is less than the second learner, then second learner will transfer his knowledge to the first knowledge to the first learner. So this is how this can be achieved, and this is the end of the second phase. So what is observation? I have tested in many scenarios, and we have found when you once pass through the teaching phase, learning phase means your first iteration is over, you will get the improvement in the result. This may be not the optimal. So you have to decide that you want the optimal result or you are satisfied with some improvement. So it depends that how many iterations actually you are ready for, because this may require 5 iterations or 10 iterations. So how you find that the result is optimal now? If 2 successive iterations are not going to change the value of the objective function, that means you get the best solution. So if you look at the features, the best part is there is no need of any algorithmic specific parameters to run this algorithm. It's easy and specific because the idea is straightforward. It's based on teaching learning methods. Lower number of iterations are there. That's the best part, and it's speed up the process, because in the learning phase, each individual learners is interacting with each other, and this involves a kind of amortization in the process. So overall, the process will become fast, and it can be applied to many problems, like if you want to find the optimal way of combining the services in a dynamic environment, or you can say optimal service composition for on-demand system. This is very good approach. You can do the estimation of reliability parameters by using this. You can use it for decision making in a multi-criteria problems. So these are the different areas where you can apply. So this is all about the idea of TLBO. So in the present form, if you look at this algorithm, this is a fantastic algorithm, but still I feel that many of the dimensions have not yet extracted. We can do more in this. You can search for a newer dimension in this approach, like there may be a one teacher teaching many courses, okay? Or you can apply different credit to each courses. So these are different variation, different criteria that you can incorporate in this present form to make it more smarter and applicable in different scenarios. That's also possible. That's up to you, that how much you can understand this and how you are able to apply this kind of scenario to the real world problems. So in conclusion, I want to make a question that can't we make a principle that to solve any problem, we'll look into the nature's approach. So generally, if you want to solve a problem, we start with the problem statement, and then we end with the solution. But in the natural phenomena, first you have to look at how the nature is behaving, and then we have to match that how this phenomena can be used to solve our problem. So once you have realized that nature has giving many phenomena which are actually very much creative, you can readily able to apply these techniques. And applying these nature-based techniques is kind of creative things. Means when you go for this kind of approach, there is a requirement of analogical thinking. You have the capability to do the map from biological to technical. You must have an understanding of natural processes, the biological processes, and then you must be able to map this into the technical aspects which you are looking for. It also needs a visual thinking. You must be able to visualize the phenomena which is existing in the nature, and then you have to relate these phenomena to solve your problem which is having in your hand or which you are interested to solve. It also involves the meta thinking, that is called thinking about thinking. We are not only interested to design the system, but actually we are looking to design the process. The main challenge of this kind of approach is you need to understand the biological phenomena, and the challenging part is you must able to relate mathematically that this biological phenomena is actually very efficient to solve a particular problem, but how can I mathematically represent to get my work done? So you can see that there are a lot of changes are happening in computer science, but if we change the way we take the things, if you look at the natures and then start thinking to solve the problems, we can get fantastic results. So this is all I want to say to you. Thank you very much.